Hello, Algebra 2 students. This is Mr. Myers. I'm going to go over horizontal asymptotes in this video. In my last video, we talked about vertical asymptotes. So in this video, we want to discuss the horizontal asymptotes. While the vertical asymptotes are much easier to find because all you have to do is determine what numbers make the variable cause the whole denominator go to zero to find your potential vertical asymptotes. The horizontal asymptotes are going to follow one of three rules. So if we can simply learn the three rules of a horizontal asymptote, we can find the horizontal asymptote. The first rule is if the exponent in the numerator, and we're talking the largest exponent, is smaller than the largest exponent in the denominator, you're going to have a horizontal asymptote at y equals 0. So in this case, we have x minus 2 all divided by x squared plus 7x plus 10. So the horizontal asymptote is going to be y equals 0 because, as you can tell, the exponent on the variable in the numerator is 1. If there's no number there, we just assume or assign 1 to it. We know it's 1. And the largest exponent in the denominator is 2. 2 is larger than 1, and so it fits the first rule. In the second case, we have 2x squared minus 3x plus 2, all divided by x minus 3. In this case, the exponent in the numerator is largest than the exponent in the denominator. If this occurs, we have no horizontal asymptote. And I should put no horizontal. There is a vertical asymptote at x equals positive 3 because positive 3 would cause the function to be undefined at x equals 3. Okay, so that's our first two rules. Rule number 1, if the exponent in the numerator, and we're talking the largest exponent, is smaller than the largest exponent in the denominator, you have one horizontal asymptote, and so y equals 0. In the second rule, if the exponent in the numerator is larger than the exponent in the denominator, there are no horizontal asymptotes. And the final rule is if the largest exponent in the denominator is the same as the largest exponent in the denominator, you are going to have a horizontal asymptote at the ratio of the leading coefficients. The largest exponent will determine what your leading term is. If you write a polynomial in standard form, you always put the largest exponent first, and the coefficient of that term is the leading coefficient. So here we have a 3 as a leading coefficient. Here we have a 4 of a leading coefficient, and our y, or our horizontal asymptote, will be 3/4. Now, earlier on, we had you divide that out to find it, but as we learn the rules of horizontal asymptotes, we discover we do not have to divide it out to find it. All we have to do is look at the leading coefficients and find the ratio, which is a fraction. Remember, a ratio is a fraction. It doesn't mean you always have to write the number as a fraction. It just means it can be written as a fraction, and you have found your horizontal asymptotes. Now, before I go, I want to show you the graphs of all of these and show you that these are the asymptotes. So in the first one, I have highlighted here, we said that the largest exponent is 1. The largest exponent here is 2, so that means the exponent in the numerator is smaller than the exponent in the denominator, and we have a horizontal asymptote at y equals 0. Now, I do want to point out something here. I discovered earlier on that we call this an asymptote, but I misinformed you when I said a asymptote is a line that a curve approaches but never crosses. That is true for vertical asymptotes. A curve can never cross a vertical asymptote. However, curves can cross horizontal asymptotes and can cross slant asymptotes. And we are not going to be talking about slant asymptotes in this class. But as you notice, the left-hand side of the curve approaches 0, but it will never cross that line. The right one will cross it, but it'll stay really close to that line. So I did want to clarify that point, that on a horizontal asymptote, there are situations in which the curve can cross it, but notice that the curve stays really, really close to that horizontal asymptote. So that is one piece of information I wanted to give you so that you are not going around saying curves can never cross asymptotes. That is true for vertical asymptotes, but not true for horizontal asymptotes. Okay, our second case, we have the exponent larger in the numerator than in the denominator. Look, you can tell there's no horizontal asymptote here. This curve does um, uh, loops around and goes back down, and there it doesn't approach a line. It does seem to have a relative maximum right around a half, but that would not be an asymptote. And also notice that there's a huge gap right here where you have a relative maximum over here around, somewhere around 5. But the huge gap, so neither side of the curve is approaching any horizontal line, so it does not have a horizontal asymptote. In our final case, we have this curve where the exponent in the numerator and denominator are to the same degree. And so the ratio between their leading coefficients is 3/4. I already put in y equals 3/4, and you can tell that both ends of the curve will approach that y equals 3/4. But in this case, neither side of the curve will cross over that asymptote. Hope that clarifies and helps you understand horizontal asymptotes. I look forward to seeing you in class, and have a great day.